Limit as x goes to 0 of the secant of x minus 1 over the sine squared of x. The first thing I'm going to do is try plugging a 0 in for each of the x's. That will give us the secant of 0 minus 1 divided by the sine of 0 quantity squared. Now the secant of 0 is 1 over the cosine of 0, which is a 1. 1 over 1 is a 1. Minus 1 over the sine of 0, which is a 0, squared. 1 minus 1 is 0. 0 squared is also 0. And we have the 0 over 0 indeterminate form. Now this is resulting from trig functions which are right now mismatched. One of them is squared, and you can try a Pythagorean trig identity with it, but that'll change it into cosine squared, which still doesn't match the numerator. The numerator, because it's a trig combination, could be multiplied by a trig conjugate. That's also a possibility. Let's maybe give that a try. And we have secant of x minus 1 over sine squared of x times the trig conjugate of the trig combination. The trig conjugate are the same two terms but opposite sign between them. So that'll be sec of x plus 1. I'm going to multiply the numerator and denominator both by that. That's a form of 1, so we don't change the value, we just change the look. We have conjugate pairs in the numerator. We're going to FOIL the numerator out. First, secant of x times the secant of x is the secant squared of x. Outside, secant of x times a positive 1 is a positive secant of x. Inside, negative 1 times the secant of x is a negative secant of x. And then last, negative 1 times a positive 1 is a negative 1. After multiplying by a conjugate pair, the outside and inside terms will always be equal value and opposite sign, and they will cancel each other. Now the denominator is not conjugate pairs, and therefore we will not FOIL or distribute. We will keep it in its factored version. Now the numerator has a Pythagorean trig identity available for it. The original version of it is tan squared of x plus 1 equals secant squared of x. And we can subtract 1 from both sides so that we have a secant squared of x minus 1 on the right, and you can see that equals to tangent squared, and that's what we can replace the numerator with, is tangent squared of x. Now that hasn't changed our 0 over 0. We still have the 0 over 0 indeterminate form. In the numerator, the 0 is due to the tangent, and in the denominator, the 0 is due to the sine. However, tangent is sine over cosine, and we're going to be able to write it that way so that maybe we can get the signs to cancel each other out. So that's going to be our next step. And we have limit as x goes to 0 of tangent squared is sine squared over cosine squared over that denominator, which I'm just going to leave alone. So it'll just be sine squared of x times the secant of x plus 1. Now because we have a fraction in the numerator, we're going to need to take the denominator fraction, which I'm therefore going to write it as a fraction by putting it over 1, and reciprocate it and multiply it. So we have limit as x goes to 0 of the sine squared of x over the cosine squared of x times the reciprocal, which is 1 over sine squared of x times the secant of x plus 1. And we can now multiply those fractions with each other, which gives us the limit as x goes to 0 of, in the numerator, sine squared of x times 1. In the denominator, we have cosine squared of x times sine squared of x times the secant of x plus 1. Now we still have 0 over 0. We haven't eliminated that just yet, but what's making 0 at this point is the sine of x, and it's being squared, but 0 squared is still 0. And therefore we can cancel those factors that are making 0 over 0. That leaves us with a 1 in the numerator. So we should have, at this point, eliminated the 0 over 0 indeterminate form. I'm just going to rewrite what we're left with. And now we can try plugging a 0 into the remaining x's. That will give us 1 over the cosine of 0 quantity squared times the secant of 0 plus 1. So 1 over the cosine of 0 is a 1 squared. The secant of 0 is 1 over the cosine of 0, which is 1 over 1, which is 1 plus 1. 1 squared is 1. 1 plus 1 is 2. 1 times 2 is 2, and that gives us 1 over 2.